Hello everyone. This project that we are presenting is a research learning project titled Data Driven Urban Planning using GIS, machine learning, and drone mapping. The goal of this work is to explore how data driven methods can support better urban planning decisions in Indian cities. Indian cities are increasingly facing challenges such as rising urban heat, traffic congestion, and unequal distribution of green spaces. These issues directly affect livability, public health, and environmental sustainability. One major reason these problems persist is the way urban planning decisions are currently made. Planning often relies on fragmented data, low resolution maps, and static or intuition driven approaches. As a result, cities experience higher surface temperature, limited access to green spaces, and inefficient traffic movement. This leads to our central research question: how can GIS integrated machine learning and optimization help identify optimal locations for green spaces, water bodies, and congestion mitigation strategies in cities? To address these questions, we propose a GIS driven decision support framework. This framework integrates drone based aerial imagery, satellite data, demographic information, and machine learning models to generate optimal urban intervention maps. Drone surveys provide high resolution imagery of parks, roads, rooftops, and water bodies. Satellite data adds city scale context such as vegetation, indices, and land surface temperature. These are combined with the census and traffic datasets within a GIS environment. The methodology combines three components: drone based data acquisition, spatial machine learning, and multi objective optimization. Each component feeds into the next to form a unified decision making pipeline. First, spatial features such as NDVI, built-up index, and surface albedo are extracted from aerial imagery. Second, machine learning models are used to predict land surface temperature and congestion intensity based on these features. Now, the strategy validation is that the approach is supported by existing research. Machine learning models such as random forest and XGBoost are widely used for urban heat island prediction. Drone satellite data fusion is known to improve spatial resolution and accuracy, and multi-objective optimization is a standard technique in land use and transport planning. So the project milestones is structured over 7 months, starting with data collection and pre-processing, followed by modeling and optimization, and finally analysis and reporting. The machine learning models focus on predicting land surface temperature and extracting spatial features. The optimization framework balances multiple objectives such as reducing urban heat, improving green space access, and avoiding congestion heavy areas. This project is led by Mehak Priyadarshi with a background in mathematical modeling and data driven analysis. The Aero Modeling Society contributes through drone operation support, safety guidance, and collaborative feedback. Risk mitigation. Key risks such as drone flight restrictions, weather constraints, and data limitations are addressed through the use of permitted zones, open datasets, and cross validation strategies. The project scope is intentionally kept focused to avoid overextension. The resource ask is that this is a low-cost research-focused project. The primary requirements are access to GIS computing resources, satellite datasets, and mentorship rather than significant financial investment. Why now? Urban climate stress is accelerating rapidly and cities need better decision support tools now. This project aims to contribute a scalable, research-grade framework that can inform sustainable urban planning decisions. Thank you.